Now the next problem is kind of important because it's getting us up to the point where we can work with standard normal calculations and non-standard normal calculations, which is sort of an important part of being a data scientist. These should be fairly natural things to work with for people. So it says, suppose the number of web hits to a particular site are approximately normally distributed with a mean of 100 hits per day and a standard deviation of 10 hits per day. What's the probability that a given day has fewer than 93 hits per day, expressed as a percentage to the nearest percentage point? So let me switch over to my notes, and I'm going to draw the relevant normal distribution. So here it is. It's 100 is the mean, and it wants to know what's the probability of 93 or fewer hits per day. So it wants that area. Well, we need to figure out how many standard deviations below the mean 93 is. So we do that by taking 93, subtracting 100, and dividing by the standard deviation, which is 10, which we get negative 0.7. So let's, so we don't know that standard normal quantile off the top of our head. So why don't we go to hw2 and type in pnorm negative 0.7. So if I type in pnorm negative 0.7, then I get 24%. I would also add that R can just do this calculation for you. You don't actually have to convert it to standard normal quantiles. So as an example, if I were to just type in pnorm 93, where the mean is 100 and the standard deviation is 10, it's going to give me the exact same answer. Probably the most common mistake you would make on this one is to accidentally do pnorm 0.7 by itself, which is 0.7 standard deviations above the mean and lower. So that would be this probability right there, so 107 and lower. Okay, so that's an important distinction. 24%, submit, and there we go.